Alright, so this is our second video around matrices, second and last I should say. So recalling that the meaning of, say, this is 5 of some variable plus 2 of some other variable is 3, or that should be a 1. 5 there, 2 there is 1, then if it instead has zeros in the first two spots, so we'll just look at two variables right now. So let's say we have 1, 2, 3, and then we have 0, 0, 0. Then that says x plus 2y is 3, and no x's plus no y's is 0. Which for any x and y ought to be true. So this actually doesn't give us any information whatsoever. So that means that all of these, everything that fits this bill is a solution to the equation, which you'll recognize this as the standard form of a line. So this is a line full of solutions, infinitely many solutions, all on this line. So we could report the results as any x you want, and then using this, 2y equals 3 minus x, y equals 3 minus x over 2, so 3 minus x over 2. So these are all the solutions, where y is whatever y can be solved to be in terms of x, and x is just any old x that you want. There's another situation that can occur, so that's the infinitely many solutions situation. What if instead, though, you had 0, 0, 1, or 5, or pi, or negative 1,000, or anything other than 0? Then the last line says I have no x's and I have no y's, and somehow magically that means I have 1. This never ever happens. So there's no solution to this one. So if you end up with all zeros, if you have a 0 on the right-hand side, that means you have infinitely many solutions. If you have anything other than 0, then you don't have a solution because it's a lie. Okay, so in this case, we have 0, 0, 6. There are no situations with 0, 0, 6. So you have infinitely many solutions would have been 0, 0, 0, and the one solution is when you had, say, 0, 1, 6, where you don't have zeros on the left-hand side. Okay, here we have solved by Gaussian elimination or Gauss-Jordan. I'm going to do this another time or two by hand just so you can get the gist of this, probably just one time actually. So on the first pass we have 3, 12, 21, 1, 4, 3. This all divides by 3, so I'm going to do 1/3 row 1 goes to row 1. And then taking this one, remember I want a 1 here, which I have. I want a 0 here. So 1 minus 1 is 0, so row 1 minus row 2 goes to row 2. Row 1 stays the same. And I get 1 minus 1 is 0, 4 minus 4 is 0, 7 minus 3 is 4. So at this point I can say no solutions, because this is never true. So this one has no solutions. This one I'm going to go ahead and put in the calculator. Weird things are happening. This one I'm going to go ahead and put in the calculator. Edit. So I have 3 variables, so 3 rows and 4 columns. So that part's already correct. X, Y, and Z are in the correct order here. So 1, -2, 7, -14, And then this one, x, y, z. So all of these, I guess, are in the correct order. So 10, 20, 70, negative 140. The fact that this one is 10, oh, I missed the negative 20. This one is 10 times the previous one means that those are actually the same line. If we divided by 10, we'd get the same thing. And that means that I only really have, at most, 2 lines and 3 variables, so I'm going to end up with infinitely many solutions, but we will just go ahead. Put these in. Negative. Oh, and this one appears to be 1/7 times the top one. So we will really have infinitely many solutions. I hate it when I do that. 1. Quit. Heavens. Okay. Matrix. Math. B. Matrix. So in this case, we have this relationship, and then we have 0, 0, 0, 0, 0, 0, 0, 0. So we really have everything would have to be written in terms of x. This has infinitely many solutions, and not even in a kind of easy way where we can easily write everything in terms of x because we have just one line for all of them. So it's the line that fits this description, period. Okay, so this is similar to the situation we just had. So we would have had the x, y, z such that x minus 2y plus 7z is negative 14. We have a similar situation here. It's kind of annoying that's all multiplied by 3. But anyway, the question is, which of these can be plugged into there and it be true? We're just looking for anything that's a solution. So the first one, x is 3, so negative 3 times 3 plus nothing, does that equal 60? And the answer is no, it does not. It's negative 9. Here, negative 3 times 20, or times negative 20 plus nothing is this 60? Yes, it is, so you would tick that little box. This one we would put in 10 for z, so 0 plus 6 times 10 does equal 60. The next one we would put in 10 for y, so 0 plus 12 times 10 plus 0 does not equal 60. Then we would put in 4 for y, 0 plus 12 times 4 plus 0 also does not equal 60. And the last one we put in 5 for y, so 0 plus 12 times 5 plus 0, and that does. So those are the 3 solutions where either x is negative 20, or y is 5, or z is 10. But of course there are infinitely many solutions where it's not the case that 2 of them are 0. Alright, so we want to use a graphing utility to find reduced row echelon form of this, and then solve it. So 3 by 4, negative 4, negative 14, 16, negative 118, 2, 4, -2, 44, 1, 3, -3, and 27. And quit. Matrix math. So we end up with this, which is what you would put there. And the result of this then would be x plus 3z is 12, x minus 2y is 5. So from here, 3z is 12 minus x, z is 4 minus 1/3 x, and from this one, x equals 2y plus 5, 2y equals x minus 5, y equals x minus 5 over 2. So the solution set would be x, y, z. So you always just leave the first one, let it be itself, and write everything else in terms of it. All right. So that's all of this. I'm going to send out the review. If we need more practice, the final exam review supplied by the department. If we need more practice on doing this by hand, then we can address that next week.